Today we are going to learn AVL tree with LR rotation. So suppose this is a tree is given. So first we will cross check balancing factor. So as 16 there is no child, so 0. 39 there is no child, so 0. 30, one child on left hand side, one child on right hand side, so plus 1 minus 1, 0. 76 there is no child, so 0. 44, two levels on left hand side, so plus 2. One level on right hand side, so minus 1. Plus 2 minus 1, so plus 1. It is balanced, no problem. Now suppose if we are inserting 37. We are inserting 37. So where we should insert? We should see the binary search tree property. So we are able to see that this is a root. Root is 44 and we want to insert 37. So it will come on left hand side. And this is another root, that is 30, and 37 is more than that, so it will come on right hand side. So again we will see 39 is a root, so 37 is less than 39, so it will come on left hand side. It will come on left hand side. So we will insert 37 on left hand side. So we can say that left sub, this is right subtree, because 44 is a root, so 76 is a right subtree and 30 is a left subtree. So we have inserted the 37 on left subtree right side. So again we will see the balancing factor of this. We will see the balancing factor of this. So I am writing here again so that it will be easy to understand what is the balancing factor of this. So 44, 30, 76, 16, 39 and 37. So once we are inserted 37, so balancing factor of this will be 37, there is no child, so 0. 39, there is one child on left hand side, so plus 1. 16, there is no child, so 0. 30, one child on left hand side and two levels on right hand side, so plus 1 minus 2, so minus 1. 76, there is no child, so 0. 44, there are three levels. You can see 1, 2, 3. Three levels on left hand side, so plus 3. One level on right hand side, so minus 1. So plus 3 minus 1, so it will be plus 2. It will be plus 2. So it is not balanced, as we are able to see. Whenever balancing factor is more than 0, 1 and minus 1, then it is not balanced. So we have to balance it. As we have inserted 37 on left hand side, right, so it will be left subtree on right hand side, so it will be LR rotation. What rotation we are going to use? LR rotation. And LR rotation is double rotation. LR rotation is double rotation. So we need to do it in two ways. Double rotation. So first we will do RR, then we will do LL. LR rotation means first we will do RR, then we do LL. So now we'll see how we do RR. So RR. So RR we will perform in the subtree where we have inserted the node in the subtree, only this side. We will do this one only. We will not change the rest of the tree. We will change only this tree. So we will do RR rotation, and we know RR rotation means we need to shift it on left hand side, because RR rotation, so we will shift on left hand side. So when we shift this tree on left hand side, so 39 will go up and 30 will come down. So we will see here how we will do. 44 and 76 will remain same. We are going to shift only subtree only, and because RR rotation, so we are going to shift on left hand side. So 39 will go up, 39 will go up, 30 will come down and 16 will come down, and what is there? 37 will come over here. This is the middle rotation, so we will not cross check the balancing factor here. This is the middle rotation. First we are doing RR, after that we will do LL. So this is RR rotation, this is middle rotation, so we will not cross check balancing factor. So after RR is completed because we have shifted the subtree on left hand side. So 39 will go up, 30 will come down, 16 will come down, 37 will come over here. Now we will do LL rotation. Now we will do LL rotation, and LL is the final rotation, so we will perform it on the entire tree. So what we will do, we will shift it on the right hand side, because this is LL rotation, so we are shifting it entire tree on the right hand side. Because we are shifting it entire tree right hand side, so 39 will go up. 39 will go up. This is RR rotation. Now I am doing LL rotation. So 39 will go up, so we will see here 39 will go up, 44 will come here, 76 will come over here. and 39 will go up, so 30 will come here, 16 will come here. Now 37 we have to see. So 37 will come here only because it is according to the binary search tree, because 39 is the root, so it can come on left hand side only, and 30 is the root, so it can come on right hand side only. So it is correct. Now we will see the balancing factor. So 16 there is no child, so 0. 37 there is no child, so 0. 76 there is no child, so 0. 44 there is one child on right hand side, so -1. 30 one child on left hand side, one child on right hand side, so 0. 39 two levels on left hand side, two levels on right hand side, so +2 -2, so it is 0. So we are able to see the tree is balanced now. Tree is balanced now because balancing factor are 0, +1 or -1, right? So in that way we can do LR rotation, and RL rotation is mirror image of it, or we can say just like it only, as we have inserted left subtree right side, that's why it is LR rotation. If in the similar way, if we insert the node on right subtree left side, so it will be RL rotation. And in RL rotation what we will do? In RL rotation what we will do? First we will do LL, then we will do RR in the similar way. So for LL we shift the tree on right hand side, and we will not cross check the balancing factor because it is the middle one. And once after that we will do RR rotation, means we shift the tree on left hand side, then after that we will cross check the balancing factor. So LR and RL are approximately similar.